Yeah, today we are going to discuss about area of a arc sector, sorry, area of a sector and a segment. Segment, right? Okay. So initially, let's try to identify how do you find the area of a sector. When you work about a sector, means it's just somewhere over here arc sector, and here the radius is r and angle is theta. So this area you can find by the formula half r squared theta. Now let's see, sometimes they might ask you to prove this context. How to prove this theory, right? So you may need, no, it's not a must to memorize, but sometimes it has a chance of asking the proof of this. It's not that hard to work it. So we know that if you get a full circle area of a full circle. What is the area of a full circle? We know that it's pi r squared. Then you can say, if you go ahead with some complete angle over here with the radians, that is equal to how much? 2 pi pi. So you can say angle on a full circle. Full circle, that is equal to 2 pi radians. Then if you want to find the area of 1 radian sector, it's equals to pi r squared should divide by 2 pi. That is done up to how much? R squared divided by 2. Then you can say area of theta radian sector, that is equals to r squared over 2 should multiply with theta. So from here you can get the area of a sector with angle theta as the formula half r squared theta. That's a way of proving this concept. Okay, so you should know how to get this fact of it. Right. Then let's go ahead with one question and let's try to understand it. What kind of shapes they can ask you. They might give you a question somewhere like this. They have given arc sector. This is 5 meters and this is 0.8 radians. They ask us to find the area. Find the area. So you can find the area by the simple formula half r squared theta. That is half into 5 squared into 0.8. So this is turned up to 5 squared is 20. 25 into 0.4. It's 10 square meters. From here you can get this answer for that. Okay. Sometimes they might you change a question in this way. They might give you some kind of a question similar to this. Here the angle is 0.2 and radius is given. They have given that the area is, we will get 3.2 square meters. They ask us to find r. Then it's simple. Simply you can say a equals to half r squared theta. Then area is 3.2 over 1 over 2 into r squared. We don't know theta is 0.2. So it's turn up to work out make a simplify 0.1 r squared equals to 3.2. Therefore r squared equals to 32. R squared is 32. Therefore r become square root of 32, that is equals to 4 root 2 meters. So simply you can get this answer. Now sometimes they might be diverge this one into a question like this. Here the angle is not given, r is 5. So you can say, given that area is 2 square meters, they ask us to find theta. Right. So simply you can say area equals to half r squared theta. This is in actually it's 2 to half r squared. We don't, sorry, it's 5 squared into theta. So this is turn up to, then theta turn up into 4 over 25, that is 0.16 radians. That is how it comes. So, okay, so that's a way of getting this kind of situations. Sometimes these are the objectives they request you to get it, and that's a way of getting this answer for this kind of questions. So this whole thing is there, right? Yeah. The next fact we are talking about is area of a segment. We did discuss it about a segment today before we try to identify the area of a triangle today. Suppose that you get some kind of a triangle just like this. If this length is A, and if this length is B, and if this angle is theta. There are two ways of getting the area of a triangle. First one is if it's a right angle triangle, not a problem. It's the base and it's the height. If it's a right angle, you can say area equals to half base into perpendicular height. If it is not a right angle triangle, somewhere like this, you can find the area over here by a very simple formula what you learn in our IGCSE, half into AB into sine theta. But remember that this theta should be the angle in between the two sides. Other than that, if you have these two sides with this angle, anyway, you have to find this angle to find it, or you have to find this length over here. Whatever the technique you have to use, and you can obtain the answer over here. Right. Now let's see how do you find this area of a segment. Segment is a shape like this, Pute. The first kind of a segment is it's just like this. It's like this way around, right? They are referring to this area. Yeah, this is the area what they want us to find, right? So this angle is theta and this radius is r, right? You can find this area by this format. Initially, we can get the area of this segment. Out of this area of this segment, this angle is theta and this is r1 of this segment. We need to identify the triangle of it. Right. Okay. This is pretty simple. Area of a segment you can find by half r squared theta. Half r squared theta. And we know that if this length is r, this length also turn up to how much r? This one also r, because you know that it's a radius of the same circle. So this one also r. Then if you apply into the previous formula half AB sin theta, because since it's a right angle triangle, so you can say half AB r into half AB sin theta. Then this is turned up to half r squared theta minus half r squared sin theta. Right? Okay. That is the total area formula. Or if you want, you can take this half r squared out. But literally, when you are working out it, you need to work out because it's simplified. This way, you can get it. That's the general format of getting the area of a segment. I'll make it a little bit small, then you can see the entire context at once. So that is the application over here to get it. And you can try on this kind of a context to get the answer for area of a segment, right? Let's go ahead with the question. Let's try to understand this. Yeah. So we will come up with the question somewhere like this way around. So this have given this is 0.4 5 meters and 5 meters. They need to find the area over here. The question is find the shaded area. Yeah, so you can say you can find the shaded area A is equal to area of arc segment half r squared theta. 5 squared into theta is 0.4 minus half A into B. 5 into 5 into sine 0.4. Here there's one thing you have to be a little bit concerned because we know that here if you put 0.4, the value is given in radian. Therefore, before you enter to the calculator, you have to operate your calculator in radian format. It doesn't make impact for this part of it. For this part, it doesn't make impact, but even in knowledge the trigonometric relationships like this, you have to be very careful about this kind of situation. So initially, if I put half into r squared into theta 0.4, that is 5, minus if you put this one, put it half into 25 into sine 0.4, that will be sine 0.4, right? So this value should be turned up to 4.86787. So that is turned up to 0.13 square meters. That is the answer for that. That's the area of the shaded region. Right? Okay. Now let's go ahead with the another question, just like this. They might give you the angle over here, and this is 2 meters. Given that area is 0.2 square meters, they ask us to find theta. Right. Okay. Given that area is, I just mark the area over here. This much, this one. So in this case, we have to form some kind of a relationship for this. Then only you can get it. No, sorry. Find the, sorry, theta is given. I just made a mistake. Find R. Right. So what you can get here is that you can say 0.2 area is equals to half. I'll just get this radius as R today. Just mark this one with R and R. So you can say this is half into R squared theta. R squared into 0.5 minus half into R squared into sine 0.5 today. Okay? From here you get the answer 0.2 equals to 0.25 R minus this is sine 0.5 divided by 2, that is turned up to 0.24. 24 R. From here you get 0.01 R equals to 0.2. Therefore R is equals to 20 meters. That's how it comes with it. That's a way of getting this kind of a question. Right. Okay. Yeah, right. Then what kind of other type of questions they can ask you? They might give a question somewhere like this. It's an art sector and it's like this. Okay. This is 8 meters and they have given us this length is 2 meters and they have shaded this region. This is 0.4. They used to ask, find the shaded region. Find the shaded region. So in this case, but then what you can understand is, and now you know that if this length here to here is 8 means this length also 8. Therefore, this length becomes 6 meters obviously. Then if you want to find the shaded area, what you can do, you can take this arc sector there. To find the arc sector, that is half r square theta. 8 square theta is 0.4. Okay, now to find the area of this triangle. How do you get it? Half 8 into this length is 8, but this length is 6. To sine 0.4. You can get this answer. So if you work out over here, you will obtain the answer like this. 12.8 minus this is 10 up to 9.35. 3.45. That's the answer for that. But another type of question they can ask you is it's just like this. They might give you a shape like this. Maybe they know. Okay. So this is given 0.5. This is 5 meters and this is 3 meters. Right. They ask you find the shaded region. Find the shaded region, right? So if you want to find the shaded region, what you can get here is that I'll get this large arc sector. The large arc sector is center is 0.5 and radius is 8. But how this way? It's from here to here. From this, you have to remove the small arc sector. Don't know, so 0.5 and radius is 5. Then how do you get it? So you can say area of the large arc sector is half into 8 squared into 0.5 minus small arc sector is half into 5 squared into 0.5. That is 9.75. 9.75 is the total area over here with the m squared, right? Okay, then they might give you a question somewhere like this way as well, but the same approach. This is 0.3 and this is r and this is 2, right? given that shaded area is 3 square meters. They ask us to find R, right? Then the same technique we use, we'll get the area, shaded area 3 is equal to half arc segment, sorry, area of the large arc segment, half r square, radius is r plus 2 squared, theta. Theta is 0.3 minus area of the small arc segment, that is half r squared into 0.3. Now you can see here, this is 0.15. 3 divided by 0.2 is 0.15. Here also 0.15. You can take it out. What do you get? R plus 2 squared minus r squared. It's that. Within 0.15. If you brought to this side, 3 divided by 0.15. 3 divided by 0.15. If I expand this bracket, it's turn up to r squared plus 4r plus 4 minus r squared. Then these two get cancels each other. 3 divided by 0.15, 20. Then you get 20 is equals to 4r plus 4. Then you get 4r equals to 16. Therefore, r is equal to 4. Radius of this arc segment become 4 meters. That's a way of getting this kind of a question. Right? Okay. That's what you can do in this kind of situations. Yes. Let's go to a couple of questions over here. Yeah, they're the same thing we are discussing about. Yeah, this kind of a question, Pute. In this diagram, AB is a diameter of a circle with radius R and BOC with the theta degrees. Given that area of AOC is 3 times of area of what do you call that? Area of AOC. AOC is 3 times of the area of the shaded region. Show that this. Let's go ahead with this and see whether how to do this kind of a question. Just use a new page. Now this is the shaded region. Right. Okay. Then they mention this much. Area of AOC. This is R. This one also R. And AOCP. They mention area of AOC. Area of AOC. AOC. Sorry, area of the triangle AOC. Sorry. The triangle AOC. I just, not the whole thing. This bit of it taken minimum amount. This blue color amount is 3 times of the shaded region. Right, okay. And what are the other facts given? Theta is given over here as theta. With an angle theta. Yes. Then you know that if this angle is theta, what can I say about this angle? That is turn up to pi minus theta. Right. Okay, let's go ahead with this. Then they have given area of AOC is equals to 3 times of area of, I just get CB segment. That's a fact they have given for them. Right. Initially, I tried to find out the area of the triangle AOC, this one for them. So here again, we can apply half R into R into sine 180 minus theta. So not 180 minus, actually this is going to, yeah, anyway, 180 minus theta, 180 means pi minus theta. So I just, because it's in radian radian format, sorry. It doesn't make a much of difference. Okay, but it's pi minus theta is the area over here is equals to area of this red color stuff. But how to get it? That is a half r squared theta minus half r squared sine theta. Okay. Then we know that this is half r squared sine pi minus theta is equals to half r squared theta minus half r squared sine theta. Then we have given a question. We can see that all the terms contains half r squared. Therefore, you can cancel them. Turn up to sine pi minus, sorry, this is 3 times of that. They mentioned this is 3 times of this. I just missed that 3 here, 3 and 3. So therefore, it's turned up to 3 times of half r squared is get cancelled, 3 theta minus 3 sine theta, right? Okay. Then what you can get here is we have to get the value for sine pi minus theta. Yes, sine pi minus theta is equals to how much? Half r squared sine theta, it's equals to, yes, that is turned up to sine theta. So, because from the trigonometry part, we can understand this concept from the Sokatova theory or Oscillatoica's theory. 3 sine theta, we just wait the quadrants and sine pi minus theta is this. Therefore, you can say 3 theta minus 3 sine theta minus sine theta equals to 0. So from here you get 3 theta minus 4 sine theta equals to 0. That's the answer what they expect you to get it today. Yeah, that's what you need to get it right. Like that you can do this kind of questions today. So you can do these questions. So here, if you need to find the segment over here, you can say, if you work out this question, this is 4 and 4, and you know that these two are radiuses, it's 5, 4. Then this angle is then how much? But if the all angles are similar, if you work out, you realize that this angle is pi by 6, 60. Then we can find, we need the shaded region, we need to find this angle. This angle is turn out to how much? Pi minus pi by 6, sorry, pi by 3, not pi by 6 actually. Pi by 3, so it's turn up to 2 pi by 3. Then you can get this area by half into 4 squared into 2 pi by 3 whole thing squared. If this is 0.2, this is turn up to 0.4. Then it's turn up to half into 5 squared into 0.4, half r squared theta. Like that you can get it. Then how do you get this area? This is 7 pi by 4 means we know that this angle. How do you get that angle? This angle is 2 pi because you know the total angle is 2 pi minus 7 pi by 4. It's turn up to then 8 pi by 8. So this angle is pi by 8 today. Yeah, that's it. Right. Okay. Then how do you get this arc segment today? This arc segment you can get half 6 squared into 7 pi by 4. That is the value over here. And this triangle, how to get it today? Triangle part you can say half into 6 into 6 into sine pi by 8. Okay, you can get that answer. After that, what you need to do today, you have to add them together and you can obtain the answer over here. Okay, so that is the way of doing this. Okay, you just if you forget this, just refer this video again and just try to catch up these things. For the following circle center, see the area shaded region is given by find the value for x. So here, simply you can write for this question a letter 12 is equals to half r squared x squared into 1.2. From here you can get this answer x. So you can find the value for x. It's not a problem. Over here, part B for this question. So you can say 15 pi is equals to half r squared. Half x squared theta is pi by 12. From here you can get the answer for x. You can get this like that. You can do any of these questions, right? Okay, first, yes, over here. So if you come up with this question today, In the diagram, AB is the diameter of a circle of radius R and BOC is theta. Therefore, if this angle is theta, what can I say about this angle? 180 minus theta, or you can say pi minus theta. Pi minus theta. Given that the area of COB is equal to the shaded segment. This entire stuff. COB, it's equal to this much. Show that this. Then how do you find this area? This area is half r squared theta. This area, how do you get it? This area you can say half r squared theta is pi minus theta minus half r squared, this bit of it. This angle is sine pi minus theta. Sine pi minus theta. Okay, from there, then they have given these two values are similar. Then what you can get here is, if I just work out over here, I'll just do it here. This is half r squared pi minus theta minus half r squared sine pi minus theta. We know that it's sine theta. Theta is equals to half r squared theta. Then you can say all the terms contain half r squared, so you can cancel them together. So this is turn up into pi minus theta minus sine theta is equals to theta, right? Then if you work out with that, let's see how to get it. Yeah. Yes, pi minus theta minus sine theta is equals to theta. Then let me see whether did I made any mistake. Half r squared pi minus theta minus half r squared half r squared sine pi minus theta. Here, this is something wrong here. Over here, so you can say sine pi minus theta again turn up to sine theta. Then it's turn up to this half r squared pi minus theta minus half r squared sine pi minus theta is sine theta is equals to half r squared theta. That's what they mentioned. The quota, if you cancel all half r squared over here, what do you get? Pi minus theta minus sine theta is equals to theta. So from this question, it's come to, I think there was a problem over here. Did I make any mistake? Sorry, but I just made a mistake here. Here, it's not the. They mentioned the triangle of COB is equals to that, not the arc segment. That's a problem I made it. So here, this is not the. They want to find the area of this triangle, not the what do you call that? Not that segment. They are worrying. They are just concerned about this area. Sorry. So you can say if this length is r and this one also r, so this is turned up to half r into r sine theta. Right. Okay, that is half r squared sine theta. It's a triangle. So that is what you have to equate with it. I just made a mistake here. So it's turned up to this way, half r squared pi minus theta minus half r squared sine pi minus theta is sine theta is equals to half r squared sine theta. Then you can cancel all r squared to this side, turn up to pi minus theta minus sine theta is equals to sine theta. From here you can write the answer. Sine theta you can take it into 1 and theta also take it to other side. Therefore you can say pi is equals to theta plus 2 sine theta. That's a way of doing this question. So you can get that answer by equating these two. Right? In the diagram below, the set of a circle is center over the radius r. It's divide somewhere over here. Calculate the area of the shaded region. So what you need to do, you can find the area of the segment minus area of this triangle. The area of the segment you can say half 8 squared into 1.6 minus area of this triangle. That is half into 5 into 5 into sine 1.6. From here you can obtain the answer for that. That's a way of doing these kind of questions. Right? Okay. All of these things you can do it. Yes. Just try these questions. If it is hard, I'll help you again. Yeah.